Sally.
And I'm Hallie.
And welcome to
Super Cool Science Experiments with Sally and Hallie. Hey guys, welcome to another fantabulous episode of SCSE.
Today we'll be learning about a super cool topic. Density.
Oh my gosh! And we'll be showing you guys a super cool 5-layer density column that will blow your mind!
The purpose of today's experiment is to determine how liquids of different densities will react when sat on top of one another.
What do you guys think will happen when we put different density layers on top of one another?
Wow! What great scientific opinions. In our opinion, we predict that the layers of liquid will rest separately on top of one another, seeing as they're all of different densities.
The liquid with the highest density, honey, will rest on the bottom and support all of the other liquids of less density, while the rubbing alcohol, which has the least amount of density, rests comfortably right on the top.
Density is defined as the amount of mass per unit of volume, or as we like to say, how closely packed together the molecules are in a certain space.
Materials! To start us off today, let's check out what materials we'll need to create this super cool at-home experiment.
To start, a tall see-through glass to put everything in.
Next, we'll start at the bottom of our density layers, with honey of course. The second layer, we'll put a little bit of dish soap. Dawn is preferred, but if you don't have any, that's okay.
Our third layer is water. Any type works.
The fourth layer is vegetable oil or canola oil.
Our fifth layer is rubbing alcohol.
After that, we just need a little bit of food coloring to color the rubbing alcohol and the water so it shows up in our density column.
To add on to our layers, a straw to carefully drop it into the cup. And a spoon, just in case.
The last thing we'll need is 5 cups to separate the amounts equally before we put them into the density column. Let's begin! Step 1. Separate each liquid into 5 different cups, each equal amounts, as you can see here.
Step 2. Dye the water and the rubbing alcohol 2 different colors so that you could set them apart in the density column.
Step 3. Add the measured amount of honey right to the bottom of the cup.
Step 4. Add the measured amount of Dawn dish soap on top of the honey. Make sure to go slowly.
Step 5. Wait about 15 minutes for the honey and dish soap to settle and separate completely because they take the longest.
Slowly add the colored water to the established layers. Make sure to go very slowly.
Step number 7. With the turkey baster or a straw, very carefully add the vegetable oil to the water layer. Make sure that the oil does not penetrate the water, that it just rests on top. As you can see here, there's 4 different layers. I know it doesn't really look like it because the green here, but we'll talk a little bit more about that in what we observed.
Yep.
So here you can see the honey layer. If you look really, really closely, you can see that this is the dish soap, this is the water, and this is the oil.
So, Hallie, did you observe anything interesting during the making of this experiment?
Yeah, Sally, I observed some super cool things. When we were putting the dish soap over the honey, it didn't mix at all. It just stayed right on top.
But why is that, Hallie?
Oh, we'll talk about that later. So, did you observe anything interesting?
I sure did. I observed that the water in the dish soap blended together more than any of the other liquids. Because of this, our column looks like it only has 4 layers instead of the 5 that we wanted it to have. Since soap and water are meant to blend together, they had less of a clear division between the 2 liquids. Maybe if we dyed the water a different color, it would have been clearer that they're 2 different liquids.
Yeah, I guess so. And let me guess, you'll talk about that later?
So, are there any other things that you observed?
You betcha! I observed that the honey, the one with the highest density, supported all of the other liquids without mixing with any of the others. It has the flattest surface, and it's the most clear in our entire column.
One of the major things that we observed during this experiment is that the oil and the rubbing alcohol switched places in the column. We know that the rubbing alcohol had the lowest density, 0.79, but we found it very odd that the oil, which was 0.92 density, ended up on the top of the columns.
Wow, that's pretty weird. Our final observation was that the dish soap and the honey took the longest time to settle and separate. The transformation lasted about a half an hour. I wonder why that is. So why does this happen?
The reason why none of the liquids in our density column mix together is all because of something called density. Density is how close the particles in a certain space are packed together.
The same amount of two different liquids will have different weights because they have different masses. The liquids that weigh more have a higher density, will sink below the liquids that weigh less, have a lower density. All of the liquids have different amounts of density.
Honey, the liquid with the highest density, 1.42, stayed at the bottom because it had the largest amount of particles packed together in its space than any of the other liquids.
Since we use varying brands of our materials for this experiment, each brand has their own secret formula, the density in each liquid might change based on that.
Conclusion! We conclude that our hypothesis was correct. We wanted to find out if liquids of different densities would rest on top of each other without blending together.
Our hypothesis was correct because the honey rested right on the bottom and all the other liquids sat right on top just based on their densities.
Thanks for watching! See you next time!